This is Matt Sosa with UCLA's Education Outreach, and for this I will be explaining what the rational method is for calculating rainfall runoff, as well as how to use a free online calculator to make that calculation just a lot simpler and a little bit easier to actually understand. So to start, you're going to go ahead and navigate to this website right here. I will include a link to this website on the UCLA Los Coyotes Middle School Project webpage. We'll do a link there so you don't actually have to type all of that in. But once you get there, it actually gives you a little quick explanation of what it really is. It's just a very simple method for calculating runoff using the variables of a runoff coefficient based off of the surface that the rain is landing on, as well as taking into account the rainfall intensity, that is to say whether it be inches per hour or just how much rain is falling on an area over a given time, as well as the area that is actually having rainfall on it. For our project, we are going to be using inches per hour just because I was able to actually find for a past rainstorm that we had, or a very small rainstorm that we had on March 2nd, an actual historical pattern for how much rain fell, and March 2nd, Friday, about 0.08 inches of water fell in La Mirada, which sounds like very little, but you'll see with using this rainfall calculator here, or runoff calculator, just how much water that actually is that had to be evacuated out of the campus using sewer drains. It's a lot more than you would think. It adds up pretty quick. So to start, you can see here it starts with 4 little boxes and one that will be your result or output. Now, what it means by runoff coefficient is actually given to you down here. It's a very simplified method, as it says, so it kind of just gives you standardized variables. In a real application, you might go a little bit more into research in depth to figure out the actual runoff coefficient, taking into account slope as well as a number of other variables for a given area. But for this project, we'll just be using the median values for each individual type. And you can see here whether it be asphalt, as we have in the parking lots on campus, concrete, or even the roofs. It's all very much the same, 0.7 to 0.95, which really is to say that 70 to 95% of the water that lands on any given surface area will actually run off. Once again, it is a little bit more complicated, depending on slope of whatever surface it's landing on as well. There's a few other things, but we're just going to keep that. We're going to go ahead and use an approximate median value, which is 0.85. So if you actually go here, you can actually adjust the rainfall coefficient, which is 0.85, or to say 85% of the water that lands on the surface will run off. And like I said here, this past Friday, or like March 2nd, we actually had 0.08 inches of water fall the entire day. And using that area we calculated from the digitization project here, you can actually see that, like I said, once again, mine is going to be a little bit less than yours, but it should be a lot higher than that. You can actually go ahead and just copy and paste that in there, and it's going to be in meters. I only digitized apparently 3,000 square meters or so. And you can also push this button here to modify your output. We're going to go ahead and use cubic meters per day for our given output. And for our drainage area, make sure after you copy and paste your total area that you calculated using your digitization, you actually go into this submenu and actually click on square meters. It's important to have the units correct for this calculator to work correctly. So once you've done that, you just go ahead and click to compute, and you can see it actually says 6.6 cubic meters of water ran off from that area that I digitized on that day. Now, that doesn't exactly sound like a lot, but you have to keep in mind that I only digitized about 3 buildings, and that this is cubic meters per day, which I know is a little bit difficult to actually understand or conceptualize how much that actually is. But if you actually click here, you can actually push it to US gallons a day, which is a little bit easier to understand or visualize at least. And you go ahead and compute that again. You can see, even though I had very small section of the campus digitized, even on Friday when it only rained 0.08 inches, you still had a runoff of about 17 to 1800 gallons on that one day. So you can see how these things really start to accumulate and why it is so important when you're planning a campus to keep in mind rainfall runoff, especially if you want to minimize the amount that actually runs off. Maybe you want to try to recapture some of that rainfall. You can see it really is a lot more than you would think, even on a very, very minimal rain day, such as March 2nd was, with only 0.08 inches within that day. This has been a very brief tutorial on how to actually use a rational equation calculator that's online, as well as a brief description of what the rational method is for calculating rainfall runoff.